When
Aditya,
Reshma, can you start? Hi, good morning, everyone. Today, very interesting topic that we are talking on Saturday, 23rd of November. This is our 191st webinar in the last 18 months. If you're following NFE, you can see we're touching upon various subjects. And this particular subject is specially designed for hospitals and on the background of where we lost 15 infants, again due to electrical fire in UP. So our webinar also is driven by what's happening around us. So we are picking up subject that is quite relevant to today's situation, what's happening in the country. And as you all know, what causes electrical fire in hospital, especially in India? Hospital are supposed to be sanctuary of healing and care. They house complex electrical system that operates 24 into 7 and support critical equipment like ICU, emergency ward, etc. And it's hospital supposed to give patient care and also operate facility for 24 into 7. The alarming remote reports indicate that electrical fire accounts for 65% of major fire in India. I repeat, 65% of major fire is caused due to electrical faulty system. So this incident not only caused massive infrastructure damage, but also pose grave threat to patients' lives and staffs. So this raises some pressing questions. Are these fire a result of negligence or lack of awareness about best practices? So could poor implementation of electrical system, inadequate fire protection measures to be blamed? So there are various reasons you can find. So today our speakers, we're going to talk about the causes of electrical fire in hospital, share lessons and case studies learned from the past incidents, and outline best practices to enhance safety and resilience in hospitals. Your participation in discussion is very important and proactive measure to ensure the hospital remain place of healing, free from looming threat of electrical fire. So I encourage all the participants to put your question only in the Q&A box. And also, if you want to talk to on the relevant, I'm again once again saying relevant subject. If you want to talk to the speaker, you can also raise your hand there, and I may take the depending on the questions that we are getting, we will take live questions. We can speak to the speaker also, but make sure that the subject, your questions and live questions all relevant to today's topic. Okay, once again, thank you for joining us today. And who are we? National Federation of Engineers for Electrical Safety. Our vision is to make electrical installation free from accident. Our mission is to achieve our vision through getting accredited of products, personal certifications, which shall focus on electrical safety by design, manufacturing, installation and maintenance of electrical product and installation by competent and qualified manpower using quality resources, including product and process and procedure. That's the mission of NFE. As you know, we've been doing various workshops throughout the country. We have finished 29. We're going to Ranchi on 27th. We're going to talk about National Electrical Code of India 2023 and CA regulations. And our General Secretary, Mr. Appavu, retired General Secretary, retired Chief Electrical Inspector of Tamil Nadu, will be talking on um, high voltage, fires and the electrical safety high voltage system. So these are the activity of NFE. I would urge everyone who's listening to us and participating today, if you're not a member, please do join as an individual member. If you're a corporate member or if you're MSME, we have an option. So this is our QR code. My colleague Lakshmi and Navya there will be posting the link to join NFE. We also thankful for other supporting partner like FSIF. We have KAO, we have AHPI and Focus for participating. Today, our keynote speaker, Mr. Deshmukh, unfortunately is preoccupied with important meetings, so he may join any moment. Once we finish this conversation, our presentation will take who are FSIF, they are Fire Safe India Foundation, empowering common man with knowledge of fire safety. They have a wonderful advisory board. They are the chairman of National Building Code, chairman of standards in BIS. So they are the fantastic intellectuals in the association. I would urge you to become a member of FSIF. So our keynote speaker, Mr. Avar Deshmukh, today he may attend lately. I will introduce him once when he comes on board. But today is very important speaker today, the president of NFE, National Federation of Engineer for Electrical Safety. Well-known name, everybody is aware of his presentations and physical, the conference that we've been doing. He is the managing director of Cape Electric and Cape Electric Power Productions Private Limited, OBO, Betterman India Private Limited, LP, Consultant India Private Limited. Most of his time is spent on standards and code, writing and preaching. So he is a member of BAS ETD 20, ETD 30, ETD 50, and National Building Code Electrical Committee. He is also a very active member. He represents India in IEC, TC64, TC81, AC37. So I'm going to unshare the screen and I would like to welcome our speaker, Mr. Gopakumar. Sir, over to you for this today's topic.
Yes, good morning to everybody. This is Gopakumar. I hope my sound is clear and the screen is also
Yes,
visible.
yes, sir,
Okay.
absolutely. You can go ahead. Fantastic.
Yeah, thank you. Mr. Dominic for the nice introduction. Welcome participants. We have, I think today we will be making a record participants. Already, I think we have about 600 and 600 plus probably. Anyway, today we are going to discuss about electrical safety in hospitals. The most important subject. I'm a member in the IEC Technical Committee MT40 FTC64, which writes the global standard on the electrical safety in medical location, which is followed all over the world. The presentation contains several parts, but I'm not going through all the parts. I have selected several parts as for today's program. The first subject, the current scenario. You know very well that the accidents are daily happening. Several accidents are happening. Multiple accidents are happening. The latest one where 15 children, newborn babies, lost their life in Jhansi Medical College. It was 10 at the first, but then the news say it's about 15. The accidents are very common. Now, one subject here is hundreds of accidents happen every day. Example, air conditioner fire from in medical location in hospitals, very common. Lot of accidents are happening. Only the major ones comes out, or it is discussed, or it becomes a news. The smaller ones, or the ones which is happening where there is no major fatalities, are not discussed in the open forum. If you look at some of the old data, example from the internet, if you look, search some of the websites, you will get this particular idea. If you look even a global way, the fire from electricity in medical locations are very high in India. This is 2009, 2010 data. This is 2011, 2012 data. You see a lot of fire accidents, and air conditioner is one of the major item. Plus biomedical equipment, the next major item. The International Consortium of Investigative Journals, journalists, according to them, several millions of deaths are or injuries or deaths are happening in medical location due to various reasons. One of the smaller reason I would say is fire from electricity or fire due to short circuit. The much bigger one which we have to talk is microshock and macroshock. These are the shock which the human being, the patient, get from the biomedical equipment due to a fault or due to a wrong practice or due to an electrostatic discharge or due to various reasons. In 1965 or 1969, there was a study in America where they found out that so many people are dying due to micro and macro shock in medical location. Medical location, what we say in electrical term, is a location where some kind of medical activity is going on. I will go through it later. But a lot of people are getting affected due to micro shock and macro shock. If we actually investigate this particular this subject in a good way, then we will realize the seriousness. It's a much bigger, much serious subject to investigate than fire due to short circuit. Why I am stressing this micro and macro shocks are in our books, in our standards, in our code of practices, safety measures are already included, but very, very rarely followed in our country, unfortunately. All of the people, those who are working in hospitals, they know what is electrocautery. Electrocautery or cauterization is a technique of burning part of a body to remove or close part of it. Now, this particular the device which is used for doing electrocautery, it is transferring energy from the machine or electrical energy into the patient's body. And in case of the energy more than the capacity, then you end up with trouble. Example, as a fault, very small fault, maybe the whole area is burned because the device is supposed to burn and cut. Now, if the energy is more, the entire area is burned. I have been working or I have been taking training classes or training the engineers of hospitals or conducting electrical safety audits, training the trainers for electrical safety audits in multiple hospitals for the last several years. So it was in several of our discussions, this cautery burning has come or we discussed, and sometimes people say, oh, monthly 3 cases, 4 cases. It's quite common. It looks like sometimes people say that this kind of burning is quite common. But please note that if the equipment and the process is proper, the chance of such kind of burning is absolutely do not exist. Now, with respect to hospital, the challenges in government hospitals, the first one is the capacity constraint. More people, more patients, less. Sometimes there is no space to accommodate them, there is no machines to accommodate them, there is no equipment to accommodate them, and they cannot deny the admission. Then it becomes a much bigger problem. The equipment are overused in the sense, for example, in case of this the recent fire accident in the hospital in Jhansi, radiant heat warmers were, it was all these warmers were running 100 percentage to warm up the babies. So and sometimes there is no spare equipment available and there is no time for maintenance because it keep on running. Once when you start the hospital or once when you become crowded, then you cannot, you really, you have literally no time to replace these goods in most of the cases. And the most unfortunate is there is no skilled electrical engineer. I will once when I go through the presentation, you will understand what exactly I mean with this skilled electrical engineer. In comparison, the private hospitals, most of the bigger ones, you see multi-speciality, super speciality, which is something like fashion nowadays. There is no capacity constraints. Admissions can be denied. Sufficient spares and equipment can be made available, proper maintenance can be arranged, the electrical engineer can be employed. It is all can. How many of the private hospitals are actually doing is a subject which we need to think very seriously. The challenge, from my experience doing hundreds of hospital visits and hundreds of trainings all over India as well as abroad in government and private hospitals. In India, unfortunately, electrical safety is a subject which is unknown even to the professional who is the electrical engineer, sometimes who is designing, who is auditing or whatever. Part 3 section 9 of NEC is it's not a part of curriculum. In most of the other nations, this the subjects of electrical safety is a part of curriculum. As a result, the engineer who comes out of the college, as soon as he comes out, he knows what to do. And the electrical engineers are, sometime available, sometime not available. Wrong practices are followed very well. Yeah, this I would say this is like a kind of a disease. Two for neutral, two for body. As a joke, we used to call two for body, two for neutral. I have a picture. I will show you. Earthing. Wrong practices. Wrong demand from biomedical equipment. Every biomedical equipment need a clean earth, a separate, isolated, dedicated earth pit. Then only he will give guarantee. Which is which is absolutely they make the biomedical companies make the environment unsafe. Electrical classification of medical locations are often unknown. Medical grouping of the medical IT systems, so for example, medical IT system in group 2 location rarely followed. It's very, very few hospitals that made it. No supplementary equipotential bonding in group 0, group 2 locations. So these may lead to fire. Similarly, I have a comparison of the small hospitals, basically a small clinic, but gradually becoming a medium size. In most of the cases, approved building plans are rare. Some big hospitals are not interested to have approved plans and keep on expanding. There are recently I was in a hospital, then they were talking about the evacuation system, and then they sort of none of our buildings have approval. So what do we do? So most of the time, I feel that this is it's a bigger challenge. The findings from smaller or medium hospitals are most often there is no responsible person, or even if somebody is there, they don't know. Example, they don't know where the electrical distribution board locates. For example, there is an incident, something is going wrong, you wanted to switch off the power, but people in that locality, they may not be knowing where the power comes from. Technicians, most of the time technicians doesn't have proper tools. No screwdriver, screwdriver is too basic, but sometimes much bigger tools are required. Example, opening a panel board, you need a panel key. Most of the time this is missing. In case of any doubt, they try to depend on somebody who constructed, and it's basically a total confusion. Similarly, in case of the safety subjects, the first one is general subjects. The safety subjects, the system, what kind of system are you using? This is most often unknown. The system looks like TT system, but there are TNCS. So basically, this is very much unknown. Fault loop impedance and disconnection is unknown. RCDs, the use of RCDs, the older hospitals, more than 10 years old, most often RCDs are not there. The new hospitals, of course, partially, maybe out of 100 circuits, maybe 10 circuits have RCDs. Safety services are there, but very rarely maintained in the medium hospitals. Fire survival installations are not very well there. Then the much bigger serious subjects, continuity of supply, class 2 medical location, EMI, EMC is very much missing. And the interesting part is, in most of the cases, the management are interested to implement the safety measures. Every management wanted to make their premise safe, but in a lot of cases they are misguided in the sense, the people, those who doesn't know the subject, are the advisors. Unfortunately, as a result, the correct information don't go to them. Similarly, in large hospitals, responsible people are available most often. 100% there are electrical engineers available, trained technicians are available, but they don't know the circuit. The circuit diagrams are not available. So this is not only in hospital, in most of our electrical installations, including commercial buildings, industrial buildings. After 3-4 years, once when we ask for the circuit diagram, nobody knows. In case of any doubt, then they will try to call somebody and try to find out what happened a few years back. Overload protective devices are installed. So chance of fire due to overload is less. But the problem is the devices are not tested. Similarly, even in the bigger hospitals, information on safety subjects. The first one is about the general subjects. The second is about the safety subjects. What kind of system are you using? Are you using a TNS system? Then the first is majority of the cases it's unknown. Fault loop impedance and disconnection is unknown. RCDs are again rare, probably a little bit more used because major hospitals safety services are installed and most of the cases they are maintained well. Fire survival installation. When we talk about fire survival installation means the entire electrical installation which can survive fire for a certain time. People always think that fire survival is about a fire survival wire. It's not about a wire, it's about the entire installation. Safety in medical locations, continuity of supply, IT system. Continuity of supply means even in case of a tripping, there are two concepts, automatic disconnection and continuity of supply. Continuity means the supply is not tripping. This is unknown. Probably this is known to 20%, but maybe if we count how many percentage of hospitals implemented this critical safety measure, I would say maybe less than 0.5% of the hospitals in the country have medical IT system. Class 2 medical location shock reduction measures are most often unknown. EMIMC is unknown. In this case also, the management are interested, but again misguided very much. So let me skip it. What exactly we are talking? With respect to electrical safety, especially in medical location, there are two approaches, safety approach. The first approach is in case of normal condition, everything is okay. Once when you go to an abnormal condition, means somebody is getting a shock, or please note that we don't talk fire, we talk thermal effect. Thermal effect in the sense, once when the electricity starts producing heat more than the allowed heat, let's say 70 degrees. Once when electricity or appliances are hotter than certain temperature, then we are supposed to disconnect the supply. The safety measures should work. So let us put it as automatic disconnection of supply. The supply has to be disconnected. The second concept is you don't need to disconnect the supply because you have critical biomedical equipment or life-saving equipment where with which because of that the patients are living. And in case of any fault, if you disconnect the supply, this is going to be another kind of problem. So for such application, you can go for the second concept, continuity of supply. I will explain this in a later slide. Now let us look at the legal requirements of electrical safety in India. We have the Electricity Act, which is passed in the Parliament. Based on the provisions of the Electricity Act, there are regulations made by Central Electricity Authority. Based on the regulation, code of practices are made by the Bureau of Indian Standards. To make a good electrical installation, you need products such as switch, socket, wire. Those are made based on the standards. Then you have the operational documents. So basically, we have a legal system in India. Example, the regulation 5 of the Central Electricity Authority regulation says the management of every hospital or every electrical installation is the word. For easy explanation, I just put the management of every hospital or medical establishment having a connected load more than 250 kilowatt shall designate a safety officer. That means if your connected load is more than 250 kilowatt, you have to have a electrical safety officer, and he has to be a degree holder with 5 years experience or a diploma holder with 10 years experience in operation and maintenance of electrical installation. Then his job is to fill up the formats provided in the regulation, and he has to record of all these formats. So basically, there is a legal requirement of keeping a person as electrical safety officer if your connected load is more than 250 kilowatt. The second one, again from the regulation 14 sub-regulation 2 says, save otherwise provided in these regulations, the relevant standards, including National Electrical Code, National Building Code, shall be followed. The word used here is shall be followed, means you must follow. In the older regulation, the wording used was may be followed, whereas in 2023, the government changed the regulation and now the word used is shall be followed. So you must follow the code of practice, which such as National Electrical Code. If you don't follow the code of practice, the Electricity Act also have a provision for punishment. It is, if you are not following the rules, regulations, code of practices, you can be the person, the owner of the building, the managing director of the company, the owner of the hospital or whatever, the proprietors, they can be put in jail for 3 months and there is an imprisonment, there is a fine. And, basically we have a beautiful legal system, which is at par with any nation such as America or Europe or whatever. So the systems are very correct. But still, what happens is like this one. This was a live video which has come few years back in an operation theater, where one of the biomedical equipment starts burning. You can see I show this video at multiples of my program because this is a very, very serious issue, because the equipment which is supposed to save the life of a patient starts burning and going to kill people. This is unacceptable. You see how you see the situation within few seconds, maybe about 90 seconds, this whole room is full of thick black smoke. 90 seconds. Similarly, this is called as the famous Virar fire accident. It was in 2021. You can see the time and the date for the April 23, 2021. And in this case, the air conditioner caught fire and approximately 17 people lost their life in this particular case. So we always say that fire due to short circuit, and we try to put the fire prevention methods. What exactly, when it comes to fire, what we talk, there is a measure, fire prevention. Prevention is better than cure. Very simple. Fire prevention is, in electrotechnology we say, avoid ignition of fire from electrical equipment or installation. So we don't use the word fire, we use the word protection against thermal effect. Means, all of you know the fire triangle. You need a fuel, you need oxygen, you need a temperature, or heat. So the electricity, the safety measures should operate once when the during the normal or abnormal use of electricity, once when the conductors, current carrying parts are or metallic parts are becoming hot, then the protective measure should work. It should avoid heating, arcing, protection from overcurrent, short circuit, earth leakage. So all these actually create a thermal effect, and the protective measure is to protect from thermal effect. Whereas fire safety and the prevention, or the fire safety measure, generally we say it is safety from fire, because you already have a fire. In case of a fire, how to detect it, how to suppress it, how to limit it or contain it in an area, and how can you select materials, use materials which do not spread the fire, or basically active and passive measures. With respect to electrical system, we are not talking about fire, please understand. We are talking about thermal effect, because electricity is not supposed to create fire. The subjects of electrical safety are part of the code of practices by Bureau of Indian Standards, the National Electrical Code 2023, IS 732 Code of Practice of Wiring, IS 17512, Safety in Medical Locations. These are some of the code of practices. The informations are from IEC 60364, a series of standards which is used globally. So our system, our standards are also at par with the standards of any other nation, example America or Europe or whatever. One of the important safety measure which has to work during a fault is called as automatic disconnection of supply. Means your supply should disconnect. There are devices which is used. All of you knows that there are MCBs, fuses, RCBs, RCBOs. So many protective devices are there in the electrical installation. The question to be asked is why these devices are not tripping once when there is a fire. So it is not because of short circuit, but it is because of the non-disconnection of these protective device. Actually, the dangerous situation occurs. So example, I'm taking tripping characteristics of a typical MCB. By putting an MCB, it doesn't mean that MCB will trip. No, MCBs have got certain, there are three type of MCBs. MCBs have different characteristics. Example, I'm putting B type 5 times IN for instantaneous tripping. That means quick tripping within 0.1 second. B-type MCB require 5 times its current, C-type MCB require 10 times its rated current. So basically, these devices work based on the amount of current which is flowing through it and the duration. So it may sometime, in some cases, for example, if the current is 1.45 times, time is 1 hour, the MCB may take up to 1 hour to trip. Let's say, for example, on the video, you saw a ventilator catching fire. Under that condition, if the current through the MCB is, let us say, 1.4 times 10 amps instead of 10 amps, let's say 14 amps current is flowing through the MCB may take up to 1 hour to trip. So a lot of cases, people think that, okay, I have an MCB, it will provide, safety. That is not correct. We should, the circuit should ensure safety. Now, how this is recorded in the standards? I'm showing you a very old standard, 1986 standard, X-ray machine from, this is IS 7620, 1986. This X-ray machine standard, you see, clause 2.17, mains resistance. The idea is MCB should trip if there is enough current through the MCB. That current through the MCB is decided by the mains resistance. The old name was mains resistance. Now it is, then later it is changed to mains impedance. Then it is changed to source impedance. And a lot of changes happened during these years. So basically, the resistance is stated in ohms. It's a technical subject. So the participants, those who are non-technical, please bear with us. The resistance is stated in ohms and is a measure of inherent resistance of the entire supply system up to the input terminals of the apparatus. Why I am showing is there is a serious subject to discuss here. This is a 1986 standard, of course. I'm sure this was part one, maybe probably the standard is even older. The standard explains how to measure the impedance of the source. Now I'm showing you an X-ray machine, which is the latest one, the modern X-ray machine. The electrical parameters, power and network requirement are included in this particular machine. I am showing it again. Power supply, 3-phase plus G means it's a TNS network. 380 volt, the machine is able to work either from 380 to 480 volt plus or minus 10%. The frequency is given, the capacity is given. Then there is a parameter called as maximum line resistance. This maximum line resistance is put for two purposes. One is the X-ray machine, while starting, it takes a lot of current, or there is a starting current, and during the starting current, if the line impedance is lesser than what is specified, the entire power supply, maybe, the voltage gets dip for certain time. In order to avoid the dip, the minimum resistances for the supply source is maintained. The second part, the same supply source, impedance of the supply source also influences the operation of the protective device. Let's say, for example, the tripping of the MCB. Now, this ideally, this X-ray machine, the manufacturer, while installing the X-ray machine, he has to check, first of all, the voltage, then the frequency, then he knows how much capacity it is. Then he must measure, I use the word must, measure the line resistance or source impedance. There should be a meter. The technician should measure the source impedance, and then only he is supposed to connect the X-ray machine. This is very much included in the standard. It is included in their manuals. It is included in their catalogs. But once when we really go to a hospital and ask you, You bought a new X-ray machine. Did the supplier measure the line resistance, the line impedance? Then most of the time the answer is nobody knows. You forget about testing. You forget about measuring it. The subject itself is unknown. I'm taking another case. This is a bigger machine. For example, the electrical installation, the electrical parameters here means it is suitable for a TNS system, three-phase neutral and P conductors. The line impedance less than or equal to 100 milliohm. Line impedance another model less than or equal to 120 milliohm. In this case also, the manufacturer, while installing this machine, he has to ensure that the line impedance or the source impedance is lesser than this particular parameter. Now, the criticality comes into picture. Source impedance is decided by the source, energy source. It may be a transformer, it may be a DG, it may be an alternate DG, it may be an UPS. The source impedance varies depending upon the source. So ideally, the supplier is supposed to measure and ensure that the source impedance is lesser than this value for all the sources, like the DG, like the transformer, like the UPS, and so on. But as I said, unfortunately, this is very, very rarely measured. And sometimes even it is funny to note that the catalog itself says it's suitable for a TNS system, but they ask for a kind of a TT system. I will show it later. So basically, the responsibility, if we look, it is not only the responsibility of the hospital owner or the biomedical engineer or the electrical engineer from the in the hospital. The biomedical equipment suppliers also create a mess and spoil the safety situation. So basically, short circuit cannot ignite fire if the protective measures work. Means if there is a short circuit, within 3 seconds, a short circuit or an energy, the heat dissipation up to 3 seconds cannot ignite fire. The protective device is supposed to operate within 0.1 second. So chance of fire is absolutely negligible. Example, non-disconnection of protective device lead to fire. So we should start calling fire due to short circuit. We should change the wording to fire due to non-operation of protective device. Maybe there is no protective device, or the protective device is oversized, or it is faulty, or it is not tested. So as a result, it don't work. Here the problem, all of us should understand that the entire problem lies on the design of the entire electrical installation, selection of the electrical items which is used in the electrical installation, how you are erecting the electrical installation. Example, electromechanical forces. Once when there is a short circuit, heavy electromechanical forces are created. The erection should be made in such a way that the electrical installation should be stronger to withstand. Verification. Unfortunately, verification is a subject which is unknown in the industry. I have a few slides I will show you. Then maintenance. Here the main problem which I see is the lack of knowledge, skills, and competency. Now let us look at what exactly is required. Hospitals are a hub of electrical installation. A lot of highly sensitive electrical or biomedical equipment are used. Most of the time, the patient is connected to the machine, so you cannot disconnect the machine and simply run away in case of a problem. So such as, for example, the dialysis machine, the ventilator. Medical electrical equipment are often be used to support or substitute vital body functions, the breakdown of which may cause dangerous situation. Patients may be undergoing surgery. Then you have medical locations where flammable atmosphere exists. Flammable atmosphere is due to the usage of, the oxygen concentration is more, the use of spirits. All this makes the installation much more critical in comparison to a normal electrical installation. All these areas are consist of equipment with conductive metal parts, oxygen-rich environment with ventilator, oxygen concentrators, anesthesia ventilators, have presence of alcohol and other flammable liquids like sanitizer, alcohol, spirits, etc. So basically, we are talking about a highly critical a fire. For the fire, it's a highly critical area. So the recommendations made in the standard are the minimum. Whatever written in the standard, always a standard writes four words: shall, can, shall, should, may, can. Shall is mandatory, should is like an option, may is a recommendation, can is a possibility. So in the standard, wherever shall is used or shall and should is used, you must follow. You cannot compromise. So we are talking about a highly critical place where electrical safety, I used the word, doesn't exist. Electricity and appliances exist, but electrical safety doesn't exist. So then the another problem is, in most of the activities, skin is bypassed. Resistance of resistance to electricity for a human being in a human being is offered by the skin. Once when the skin is bypassed, the resistance is quite less. So you cannot expect a patient to withstand, or a patient with something which is bypassing the skin, a metallic object bypassing the skin. You cannot expect the patient to withstand a voltage 50 volt like in the normal case. Conductive instruments in contact with bloodstream or heart muscles and wet floor. All these things make the entire area highly vulnerable to shocks. Physiological effect of shock is from the in the biomedical locations are very well recorded, studied, recorded, recognized in the standard. Microshock, macroshock, as I said in my earlier slide. Probably the number of patients, those who are getting affected due to micro and macro shocks are much more than the number of people, those who are getting affected due to electrical short circuit or fire from electricity. Probably multiples, maybe 100 to 1,000 times more. However, this is a subject which is unknown, or which is not at all. There is no study, so we don't know how many people are getting affected. So now let us look at how the whole system evolved, how the engineering practices are evolved. IEC 60513 made the identified the risk involved in a medical location, or in a location which is wet, which is having spirit, which is having biomedical equipment, patients are there, unconscious people are there. So the risk involved in this particular areas are identified in the standard IC 60513, and these risks are converted into engineering practices such as product standards, process standards, installation and environmental standards, and application standards. So basically, the risk is identified and the risks are converted to engineering practices and the standards are made. What I'm talking is the National Electrical Code of India, IS 732, or IS 13450, which is equivalent to IEC 60601. For example, almost all biomedical equipment which is used in a hospital are in compliance to IEC 60601 because it's mandatory required. Whereas the installation standards mandatory, it's not mandatory. As a result, most often product standards are followed, whereas installation and environmental standards are not followed. Applicable, how to handle is not followed. So first of all, the risks are converted into standards. Example of single fault in power supply. In medical location, we say a situation called a single fault condition. Single fault condition in the sense, condition of medical equipment in which a single means of reducing a risk is defective or a single abnormal condition is present. Means there is some fault. Even during a single fault, the safety measures should operate in such a way that a hazard is not created. Example, in case of an installation, that means your hospital, how to handle single fault in power supply. Example, UPS within the same fire section for supplying a medical IT system. Of course, UPS is there because affording power supply lossage is very uncommon. So, but the medical IT system is missing, or UPS that supplies number of group 2 locations. So basically, these safety measures are included in the respective standards. Similarly, Example, while maintaining one of your equipment, let us say, let me show you from the standard so that it is easy for me as well as for you to understand. So I'm talking about the standard which you can see on the screen, IEC 60601, which is medical electrical equipment, general requirement for basic safety and essential performance. So now all the biomedical equipment which you are using in the hospital are as per this particular standard. The equivalent Indian standard is IS 13450. I am searching the word single fault. You see, you can find the explanation of single fault in multiple places. The standard very clearly handles, example, single fault of medical equipment. So multiple, see, implementation of risk control, normal condition, a single fault condition. Single fault condition, you must identify the fault and you must handle it properly. This is about the equipment. Now I am showing you another standard low voltage electrical installation requirement for special installation and location, medical location. So the first one is about the equipment. The second one, this is called as IEC 603647710, which talks about the electrical wiring and the devices. So here again, I am searching the word single fault. In case of a single fault in the power supply, a total loss of power shall be prevented. This may be achieved by, the UPS or by medical IT systems and so on. So like this, similarly, the next standard, for example, IEC 62353, this is an ISIC 62305, medical electrical equipment, recurrent test and test after repair of medical equipment. Every medical equipment, once when you repair, you are supposed to ensure that the equipment is still in a good condition, which can be connected to the patient's body. As I shown the burning from the cautery machine, if more energy goes from this particular machine, probably it's a threat for the people. So basically, all these measures are identified and they are included in the respective standards. I'm showing you some of the standards here, 60601, 60364 and so on. It will be very difficult for you to remember those numbers because I can remember because this is my job. So basically, medical electrical equipment and systems, which we call as ME and MES, are made which has to be used in a location. Basically, the safety of the equipment depends upon the supply parameters as well. Example, the disconnection, single fault condition, operational protective device used in multiple supplies. So these are actually challenge. So here the most important point is coordination between electrical and biomedical engineers are essential. In several places, once when we talk, in a lot of cases, this coordination or cooperation is not really existing. One fellow think that the other fellow is demanding something which is not my job. The other fellow says he is demanding something which is not my job. The biomedical engineer thinks that, so basically, if you wanted to make a good electrical installation, there should be proper coordination between electrical and biomedical engineer, and one should understand what the other need. Very important. So equipment are classified into class 1 equipment, class 2 equipment, class 3 equipment, and the applied parts are specified. Applied part means the part which is part of the biomedical equipment, which is touching or bypassing the skin of a patient. So these are just the technical names. As I said, the mains resistance, these are, the standard for the product is made based on the requirement. I repeat, most of the cases, the medical equipment companies are not doing this particular test, which makes not only their equipment unsafe, but the entire installation unsafe. Similarly, this one, the second one, this also I explained. So those companies should, or the hospital owner, hospital management, they should be in touch with the NFE and they should ask for this particular thing. So basically, I explained about the two concept safety approach. There are two ideas. The first idea is disconnection of supply. Means in case of a fault, let the supply trip, which can be used in general locations, which we say as unclassified and group 0 locations. And this is called as earthed system. in the technical word, which we say TNTT system. The second concept is continuity of supply. The idea is, in the first concept, the protective device should trip in case of a problem. Whereas certain locations, you cannot afford to trip the supply. Example, medical locations, group 2 medical location, where vital body functions are supported by the machine. If the supply trips, you are in trouble. So such cases, you cannot afford to disconnect the supply. Example, medical location, example, safety services, firefighting. In those cases, you can go for the second concept, which is called as unearthed system or IT system. Especially in medical location, you should use a medical IT system. This IT system is for limited areas. You cannot use, sometime once when we ask this two concept, then people ask, then why don't we go for the second concept, which looks more safe everywhere throughout the hospital? You can go for it, but it will be quite expensive. It's not economical. You can use IT, you can make IT system everywhere, not at all a problem. So in an IT system, before the fault comes, you get an alarm. Medical IT system is limited to 10 kVA with special protective measures, protective and monitoring devices. So in IT system itself, we have to call two things: IT, medical IT. Medical IT offers a much higher integrity of the supply. So basically, the fundamental subject is divided into, which is called a system earthing. The future name may be energy systems. It is classified into TN system, TT system, IT system. It's too technical. Let me skip it. How to get protection from shock? Every electrical installation need protection from electric shock, protection from thermal effect, protection from voltage disturbances. Example, protection from electric shock. There are different ideas, there are different protective measures. It's not ideas, sorry to use the word, protective measures, recognize the protective measures included in the standard. For example, I am showing protective equipotential bonding and automatic disconnection of supply. This is the idea number one. This is the safety measure which has to be used in the general location, and separation is the idea which has to be used in medical location. So basically, this one, protective equipotential bonding and separation, these two are the most important safety measure, fault protective measures, which is used in a medical location. So they are classified into basic protection, fault protection, additional protection. It has to be applied based on who is handling electricity, what kind of people are involved, how frequently you are in contact with earth, what kind of equipment you are using. Medical location need additional safety measures. So basically, I'm just trying to explain you that it is not only putting an MCB to trip. There are so many other measures also act. Example, the first safety measure against fault or electric shock is called as protective earthing plus protective bonding plus automatic disconnection of supply. Any electrical installation, you cannot compromise the first two, protective earthing and protective bonding. You cannot compromise. And if you go with the idea number one, then you should automatically disconnect the supply. If you go for the idea number two, you should monitor the insulation. Now, what is protective earthing and protective equipotential bonding? I am showing a picture. Due to the time constraint, I am not explaining much. So basically, in every electrical installation, all the metal parts, dead metal parts in normal condition must be electrically bonded. See, the idea is potential do not create shock. Potential do not create arcing or whatever. Potential difference create a problem. You will have potential difference if two metallic objects in your building are at two different potentials. So accessible metallic parts, if they are at the same potential, you don't get a shock. So what do? You take a wire of certain size and you interconnect all the metal parts in your building. As a result, there is no shock. Very simple technique. This technique, for example, has been included in the National Electrical Code since 1985. I'm showing you a picture of how to avoid shock in a agriculture premise. Let's say you see there is the serial number 13, which is maybe a copper bus bar. All the metal parts in the cow shed are connected to this copper bus bar. This is again example of equipotential bonding within a cow shed. In a cow shed, in order to have same potential everywhere, or in order to protect the animals from shock, you must interconnect all the metal parts, including the concrete rebar. Figure number 3, again, how to make this particular connection. Figure number 4, again, how to make this particular, equipotential bonding. The idea is, wherever people are there, and if you are using electricity, there shall not be any potential difference which can create a shock. If there is a potential difference, the voltage has to be limited to less than certain limit, and the duration has to be limited to certain distance. So basically, you have no shock voltage in the area. This picture is for cowshed or agriculture horticulture premises, which is followed all over the world, in Europe, in Americas, all the developed countries. For cowshed, this kind of equipotential bonding is mandatory. It is followed. Otherwise, the insurance company will not pay you the insurance. They will not take the claim, or they will not get the insurance. Now, this particular picture is for a hospital. For a hospital, not for the previous one is for the cowshed. This is for the hospital. This picture was there in the National Electrical Code 2011. Explains how to make or how to avoid potential differences, how to get rid of shock in a hospital. Example number one is heating air conditioner pipe. Number 2, water supply pipe, gas supply pipe. All the metal parts are bonded to a common bus bar. So this common bus bar is called as protective conductor. So basically, protective equipotential bonding, that means every metal part, dead metal part under normal condition, must be bonded. There is a picture given in the Indian standard. Similarly, it is also explained in these particular standards. Similarly, for medical location, means where there is a patient, where there are some operations, some activities going on, the patient is connected with biomedical equipment. In that condition, you need supplementary bonding, means additional bonding. So all these wires which I am showing, these are bonding, means every metal part is bonded in such a way that absolutely in that area there is no shock voltage exists. So this kind of bonding is mandatory and very much carried out in Europe, Americas, not only for medical location, including the cow shed. For example, you saw the picture. I would like to make a strong statement here. In Europe and America, even the cow sheds are protected, or the cows are protected from shock. Whereas in India, the supplementary equipotential bonding, which is shown in this particular picture, included in the standard, is very, very rarely followed. Maybe less than 0.1% of the entire hospitals in India are following this particular safety measure. So basically, the importance given to cows in Europe and America is not even given to the patients in hospital. I'm so sorry to make this particular statement. Then the second part, the protective device should disconnect within certain time. The times are set, the impedances are made. In the regulation, we made a new word, fault loop impedance. In fact, it was not a new word; it is existing since 1966. The fault loop impedance means, to ensure tripping of your device, you must measure the impedance of the circuit. The biomedical equipment manufacturer should test it, whereas the hospital owner should test it for the other areas. So basically, the impedance measurement of the circuit is very, very important, which is very rarely carried out. So instead, what do we do? Example I am showing you from the standard IS 732, where the shock and fire, let's say protection from fire, thermal effect is explained. Here there is a note: an installation does not need to have its own earth electrode. I would like to take your attention to a very serious subject now. Most of the hospitals, example how earthing is carried out. two earth pit for neutral, two earth pit for body, two earth pit for main distribution board, two for lift, two for UPS, two for biomedical equipment. If you have 25 biomedical equipment, maybe 50 numbers of earth electrode. This is never ever written or documented in any of the standards or any science book. It's total mistake. This is one of the main reason for fire in hospitals, because if you make in this fashion, there is no, the impedance is higher, protective devices are not efficient. As a result, fire happens because the protective device is not tripping. Non-operation of the protective device lead to fire. So this is a big mistake. The second one, each of them as groups, clean earth, power earth, lightning protection. This is also a mistake because your devices won't work. Then separate. Sometimes smart people, they say, I interconnected everything under the soil. This is also a mistake. You are not supposed to follow such wrong practices. These wrong practices lead to fire because your protective devices are inefficient in operating during an earth fault. So then what do? You must interconnect all the metal parts, including the earth terminal of your biomedical equipment, to a common integrated bus bar. You must interconnect as short as possible. This is what is written pictures in the standard. And these pictures are existing since several years. But what do? We put separate electrode. This is on the left side, what you are seeing is the earth farm in a hospital in Delhi. So in Delhi, it's the land is very expensive, but still they find out or found out space to put earth farm. This is again from another installation, earth farm. People think that by keeping the earth electrode very clean, neat, and pouring water, something like this, pouring water and keeping the resistance less than 1 ohm, safety is achieved. It is not like that. The electrical safety has nothing to do with this plate or pipe in soil. I repeat, electrical safety means protection from electric shock, protection from thermal effect, protection from voltage disturbances. These things have no relation to the rod or pipe or plate or chemicals in the soil. So the idea of this chemical earth, these are absolutely mistake. So we are not talking about these things. We are talking about a properly equipotentially bonded system. In the standards, for example, the IS 3043, this picture you can find figure number 38, 40, 41. Several figures are there. It explains how to make earthing or equipotential bonding in your hospital. Let's say, for example, there is a DG. Body of the DG is connected to a common bus bar. Neutral of the DG is connected to the same bus bar. Incoming EB supply is connected to the same bus bar. So basically, it's a proper equipotentially bonded system. This is the correct way. There is no need for two separate earth pit for body, two separate earth pit for neutral and all. It's wrong. Please don't follow it. There is a subject called as system earthing, which is classified as TNS, TNCS, TNC, TT, and IT. You should select one of the system and you should follow. So here, for medical location, the recommended method is TNS. TNS means it's an earth system. There is a separate metallic. So here you can see there is a metallic fault return path and it is separate. Now I am showing you, even though these are very much included, documented in multiple standards, multiple documents, very special. Our equipment manufacturers, the multinational companies supplying crores and crores of worth materials to the hospital, they come with a very special requirement. They say this is my exclusive, and they put all kind of nonsense into the hospital, which creates actually the fire. For example, this is the demand from a cath lab. Now here you can see there are some symbols where I'm putting. You see there are some symbols. They want each of these connection to separate earth electrode. So each of these connection need to go to the earth electrode, and you see earth megar value should be less than 1 ohm. This company, which is a multinational company, they don't know the difference between earth megar and earth resistance value. Earth measuring is insulation resistance measurement. So you see, so such mistakes are existing. Now, This is additional requirement from one of the company. This is again from another company, dedicated system earth pit. Sometimes we don't understand what these people mean. They are demanding something which is absolutely against the science of electrical engineering. Example, if you wanted to have an UPS, go to the UPS standard. There is an UPS standard 62040 part 1. How to make earthing of the UPS is very well explained in the standard. How to test the earthing is very well explained in the standard. And you are supposed to make earthing in this fashion, not like separate pit. By hearing the name earthing, people think that earthing is related to the pit or the electrode which is there in the soil. It is not like that. Now you see, this is from the medical equipment standard IEC 60601, which says exceed 200 milliohm but shall be less than 400 milliohm. For certain kind of equipment, depending upon the fuse rating, you need, you see, if the with current rating 13 amps or lower, then you need to have 200 milliohm, less than 400 milliohm, less than 200 milliohm. The resistances are very well mentioned in the standard. The standard has got a lot of information. Please read the standard and do it. It is not like somebody coming with an idea and putting a wrong idea into the installation, which creates later fire. So I'm showing some of the subclasses from the standard, which these requirements are very well documented. Now, for earthing, please note that there are multiple symbols. For example, 5017181920. These are very well there in your equipment. This is an example. 50, protective earth, chassis earth, frame earth, functional earth. Biomedical equipment, you can find this particular symbol, which is equipotentiality, means this particular terminal. The potential of the terminal is close to zero. You see, all these are not connected. So if you don't do it, of course, you will be in trouble. So then what the subject? Medical locations are classified into group 0, group 1, group 2. Group 0 is a medical location where no applied parts are intended to be used. Means there is no diagnosis, or there is no, the biomedical equipment are not used on the body of the patient. Group 1 medical location, example, biomedical equipment are used externally. Group 2 biomedical equipment or the applied parts are used, or they bypass the skin. The National Electrical Code of India made this particular table, which makes the recommendation. The type of rooms are classified into 22. You can see here anesthetic room. You have to classify this as group 2 location, means you need a highly safety measures. A lot of safety measures are required. Now, operation theater, it's a group 2 location. You need a continuity of supply. You need a medical IT system. Heart catheterization room. This is a group 2 location. Intensive care unit, ICU is a group 2 location. So like this recommendation is already made in the National Electrical Code of India. Not only, as I said, this information is not from India. This is from the IEC standard. All over the world, the same systems are used, be it America or Britain or whatever. The standards also include the additional safety measures in these particular location. Example, the conventional touch voltage in general locations and group 0 locations shall not exceed 50 volt, and in group 1 and group 2 medical locations shall not exceed 25 volt. So whenever we say medical location, it is talking about group 1 and group 2. So the potential difference shall not exceed 25 volt during a fault. Group 2 medical locations such as operation theaters, ICU, etc. shall have a medical IT system in order to ensure continuity of supply during first fault. That means medical IT system is a power supply system which ensures that even during a fault, your protective device need not have to trip. The supply will continue. You are making an operation, the operation can continue, but the technician will get a warning. You can take care, or you can make a maintenance. Maybe after 3 hours, maybe after 1 day, or maybe after 2 days. After some time, you get enough time to take care. You have enough time to maintain this particular device. Now, the National Electrical Code of India is asking, it's a mandatory requirement to put in operation theaters and ICU shall have medical IT system. As I said, medical IT system, if we look at the percentage of hospitals where medical IT systems are used, I would say maybe 0.05 percentage, very much less than 1%. Then here, main protective equipotential bonding. in addition to supplementary equipotential bonding. Supplementary equipotential bonding, I have already shown a picture. So every metal part must be interconnected frequently so that the high safety is ensured. Patient environment is defined. Additional safety measure for patient environment is defined. In medical IT systems are defined. So basically, what is required is there are standards which recommend the minimum safety requirements which no one can violate or you must follow. It's a legal requirement. Example for the equipment, I'm saying some of the example. This is not, if I put the entire list, it runs to few pages. Minimum over voltage category 2, supply mains 90 percentage to 110% between any of these conductors and earth. Now, why I show this B, supply mains? Lot of technicians working in hospitals or electrical engineers, they have a feeling that if the voltage between neutral and earth is more than 2 volt or 5 volt equipment fails. This is wrong. Every class 1 biomedical equipment is capable of working with a supply mains 90 percentage to 110 percentage. Let's say 230 volt is the voltage between neutral and earth, 230 plus 10 percentage continuously. These equipment are capable of working. They are tested. 2 volt, 5 volt, 10 volt, 20 volt, 30 volt can never or they will not influence the performance of your equipment. So then the equipment, the supply impedance, which I have shown, the applied parts are specified with respect to installation. Medical locations classified group 0001 2 TNS system in the general location and medical IT in the group 2 locations, protective equipotential bonding, supplementary equipotential bonding, a lot of continuity of supply, EMI, all these are the additional required safety measure. Here, I would again say one of the biggest confusion is created by the biomedical equipment supplier. As a result, every biomedical engineer will demand the electrical engineer that I need, I have 5 biomedical equipment, a new biomedical equipment is coming, you need to make a clean earth electrode outside the building, which is, I would say, very sorry to use the word, it's really foolishness. So the biomedical equipment supplier, as I said, the first person who makes the mistake, he demands dedicated earth electrode for sensitive equipment because he doesn't know how his equipment works. He is not trained what is written in the standard and how he has to handle. This demand is a violation of standards and regulation and are the reason for fire from medical electrical equipment due to non-operation of protective device during a fault. Hence, this demand shall not be entertained. Such equipment need an independent connection to a common earth terminal. I have a figure I will show you. Medical electrical equipment and system engineers shall note that medical electrical equipment as per IS 13450 can operate with a potential of 230 volt continuously between neutral and earth. As I said, this is how earthing is made in a cowshed, and this is how we are supposed to make an earthing equipotential bonding in an operation theater. Now, medical equipment suppliers always demand a dedicated earth. Let me explain about what exactly is this dedicated earth. You see here on the first picture which I am making, each of the equipment from equipment number 1, equipment number 2, 3 and 4, separate. Now in the bottom, the internet is unstable. Is it okay?
Yes, sir.
Yes,
Okay.
sir.
We can,
Thank
no
you.
problem, sir.
Thank you. I will finish in next maybe in 2-3 minutes. So
Okay.
now this figure at the bottom is non-dedicated. So the difference between these two are, you see, if you go for the second one, which we call as, we don't use non-dedicated in the standard, we use the word earthed in group. Example, if there is a problem in equipment number 4, the leakage current or the noise will go through the equipment number 2 and equipment number 1. So problem in one of the equipment is spoiling the performance of the other 2 equipment, which is not allowed. So you should not make it. So Equipment manufacturer always demand dedicated earth or individual earth. Means from a common bus bar in the operation theater room, you must make separate connection. Don't try to loop. That is the meaning. This has nothing to do with earth pit. You can find it in our IS standards. And the maximum allowed resistance between the MET and the equipment number 4 is less than 200 milliohm. In group 1, group 2 location, maximum allowed resistance is less than 0.2 ohm. So these are very well documented. You can find this picture also in the standard. Medical IT system. Medical IT system is you electrically separate your supply with an isolation transformer. You have to have a special medical isolation transformer. You have to monitor the overload of the isolation transformer. You have to have line controllers. You have to monitor the fault of each of these line. You have to monitor the insulation of the entire supply system. You can have the entire system can be connected to your BMS or remote monitoring system. As a result, in case of an electric fault in this particular medical IT system, the responsible person will get an indication saying that, oh, look, there is a fault, and he don't need to trip the supply. He can, now everybody know that there is a fault, and you can take your own time to rectify the supply or rectify the fault. Another subject which is very important in medical location are electrostatic charge. You see here, group 2 location, required. Earthing of personnel via footwear and flooring, earth other conductor via flooring or direct connection. So actually you need additional safety measures in order to handle electrostatic charge, because group 1, group 2 locations are already conductive and already flammable. In case of a spark due to electrostatic charge, it can lead to fire. The protective measures are included in the standard 61340 part 1. The last subject of electrical installation, as I said, design selection, erection, verification. Verification, there are several subjects for verification. It is not like somebody walking from one end to the other end and identify everything. No, there are several subjects for verification. These subjects are very well exampled with respect to shock. These are very well defined in the standard. After inspection, you are supposed to make a test. There are 10 tests plus 11 tests identified in the National Electrical Code. Please note that earth pit resistance measurement is already removed. There is no earth pit resistance measurement here. So this is all talking about modern testing measures. You need modern test instruments to do all these testings. So basically, if we go to a hospital and ask, okay, what kind of testing are you doing in your electrical installation? And people say, I have done earth pit resistance measurement. As I said, earth pit resistance measurement is already removed from the standard, whereas you need continuity of conductors, insulation resistance, and all these 10, 11 tests. Medical location needs additional tests. These additional tests are included in the part 3, section 9 of National Electrical Code. Also, these are included in IS 17512 standard. You can find these particular, additional tests required and the frequency of tests. For example, functional testing of changeover device every 12 months, functional testing of insulation monitoring device every 12 months, setting of protective device every 12 months. So basically, these are very much recommended. Please note that these are the minimum safety requirements. You can make much more than the standard. If you make much more than the standard, your installation will be much more safer. So please don't compromise on these minimum requirements. Now what happens? Even though these are very well recommended, when we go to a hospital and ask what kind of safety measure are you? Oh, I did thermography. Please note that thermography is not recognized in NEC as a reliable safety measure. As I said, design, selection, erection, verification. In verification, these are the tests which are included. Continuity of conductors, starting from continuity of conductors up to voltage drop. Example, if you are doing continuity of conductor test, the chance of loose contact itself is gone, because you know that there are loose contact and you rectify at the first day itself. So your installation will not have loose contact. Whereas thermography is carried out. I repeat, this is not a recognized electrical safety measure, but if you want so this is not a mandatory as per the National Electrical Code, but if you want as an additional measure, probably you can do it. Please note that ISO has made a standard, then they deleted the standard. So thermography is not recognized in IEC or ISO as a reliable electrical safety measure. Confused by authority. Unfortunately, the NABH document also says the help of new technology like thermal imaging equipment can help detect loose connections in the system and then thereby prevent fire incidents. Unfortunately, this is a wrong assumption. Your electrical installation is not supposed to have loose contact. You have to make it in such a way. So sometime I would say the authority also make compromises or make misguiding information to the user. Now I am showing you about the last test, which is a periodic verification of medical electrical equipment. The biomedical equipment also need testings frequently after repair, before repair. These are very much documented in the standard. Please go through the manufacturer's recommendation and do it. So with this, I would like to stop the presentation. Thank you very much. I don't know how much time I took. I took long time.
You took almost, yeah, 1 hour, 23 minutes. That's fair. The subject is quite interesting, and I could see none of them, exited. They remain. We have actually a record-breaking registration. We have 910 people have showed interest for today's, and more than 70% are taking part in this session. So I was just going through a few questions coming in for Mr. Gopakumar. So I would urge those who are relevant to today's topic, I would like you to post only relevant to the today's topic. So I'll pick up few questions. There are few people who posted multiple questions. So I will pick one from each one because we have almost 30, 40 questions. So I'll pick up first one. SD Malu, who is also Chief Executive Director of FSIF. So he's asking, it's a good question. Similar to fire risk assessment audit, there should be a separate electrical instrument and conduit inspection on a regular basis. Is this a mandatory by law? Is the question.
Yes, of course, it's mandatory by law. It's mandatory by law. How it works is the last two, three slides I have shown what kind of inspection and testing is required. The Electricity Act says as per the code you should do, and the code very clearly says the code of practice very clearly included this verification. There is a format for testing. So you can put the inspection and test. There is a format, detailed format. Technically, you are supposed to fill up the format and keep it in your hand. But as I said,
Yeah,
as
go
I
ahead,
said,
sir. Go ahead.
when I made a comment, I don't know whether you noticed. This verification is a subject which is unknown in the industry currently.
But NABH, while issuing the certificate, this is from my side, we have NABH and JCI for international hospitals. So JCI, do they really go through this test certificate or a verification certificate issued by third party? Do they really insist? Because this every year it
No,
happens.
no, no.
Because when it comes to fire audit, they're very specific. Without the fire risk assessment, they will not issue the NABH or JSA certificate. We should, I think, we should have a dialogue with NABH to insist that this verification, as per the standard, it is required. So then more and more hospital will come, and I'm sure that will ensure safety of the hospital. I'm going to the next question from Tejveer Singh. Most of fire due to usage of paper capacitors of single phase motors, FCU, FFU, etc. Please guide how to mitigate.
Okay, these are parts of the equipment. The equipment standards take care of safety against fault from those equipment. These are very well documented. In case of failure in those equipment, there are protective measures included in those standards.
Okay, a very interesting question. I'm sure you will love this question by Santosh Sahu. The second question: what role does real-time monitoring of electrical system play in preventing fire hazards in critical care units? Context is saying with advanced IoT based on smart monitoring system, what specific technology or practices can hospital adopt to detect the mitigate risk in high dependency like ICU or operation theaters?
Actually, the standards, from the standard point of view, the standard do not recognize the monitoring as a safety measure. Monitoring is monitoring. This has nothing to do with safety. Safety with respect to, in case of a problem, the safety measures should work. Whether you are monitoring the safety measure or not, that is up to you. If you have money, you can do it. But example, there is a device and it should trip. Now you can monitor whether the device tripped or not, which has nothing to do with safety because you already achieved the safety. But now, if you are only monitoring that, look, there is a fault, there is a shock, somebody is getting a shock, and you monitor on the screen. By the time you read and take the action, the person is died. So there is no safety measures. It should work instantaneously. It is not like somebody should monitor and apply it. So there is a big difference actually between these two. Of course, in medical location, group 2 medical location, against first fault, the continuity of supply, there are some monitoring, insulation monitoring devices are there.
Okay,
Over to you, Chidol.
good one. What we are talking about safety, we need to prevent. Monitoring is something that is beyond safety. Okay, Satishwaran is asking, as a part of fixed installation periodic verification, we do FLIT, RCBO test and IR test, polarity test. In the hospital environment, we are not able to disconnect the power supply during verification time. Can we measure the leakage current as an alternate to IR test or to comply with IEC 60364?
No, no. We have to switch off and we have to measure. We cannot compromise.
But his challenge is hospital does not allow them to, shut down.
Yeah, but we have to do it sometime, maybe in the midnight in an operation theater. Sometimes we do test during morning, 2 a.m., 3 a.m., 4 a.m.
Hmm. Okay. Totad, the question, electrical standard IEEE speaks double earthing. Please throw some light on the double earthing where it is required or not.
I would say in a medical location, especially in a biomedical location, never follow this double earth. There is nothing like, you put take two wire and connect it to the earth pit. That is not double earth. There is a figure in the IS standard. You have a medical equipment. You have an equipment. You take two wires and connect to the common earth bus bar. So two connections are required. Actually, this idea is too old. Now, if you follow that particular idea, you actually spoil the equipment like an UPS or whatever. The earth
I think there's an internet
device.
connection, internet issue, Mr. Gopakumar. Now we
Yeah.
are there is a
Okay.
break in
Now,
your
now is it clear now?
yeah, better.
Yeah.
Can
Okay.
you
You
can
see,
you answer once again?
yeah, yeah. Instead of making this two separate connection, we must understand that modern electrical equipment or biomedical equipment are made based on the standard, the product standard. Product standard do not demand double earthing. So the terminals for earthing are made internally inside the equipment. Let's say, for example, you have an equipment which is having a terminal to connect to the earthing system of your building. If you are trying to, if somebody is demanding double earthing, and if you try to make one more earthing, you are actually spoiling the integrity of the device. Don't do it. Look at the manufacturer's catalog. Double earthing was a very, very old concept, which practically today's equipment is very risky to follow.
There's another question is asking. In hospital, electrical sockets are very close to bed. Is it good or bad?
Yeah, it is bad. It has to be a little bit distance. The distance I don't remember. It has to be kept far away, certain
So,
distances around.
again, Gaurav is asking, does that mean we should use extension cord for connecting multiple equipment?
No, you should have multiple sockets in the facility so that each of the equipment can be connected individually to the fixed socket. There should be enough sockets available.
Okay. So Mahesh Siva Prakasham, could you explain fire accident happened in Gindi Kalaigar Hospital? He's asking, do you have any case studies? Gindi Kalaigar Hospital, there was a fire last week Saturday, there was a fire in Chennai, Gindi.
Yeah, I'm sorry, I don't know about it.
Any?
Probably it's a minor one.
Okay, I was not aware. Mm, how does AC causes fire?
Yeah, AC causes fire because wrong installation, poor quality AC. Finally, the fuses don't operate, creating fire.
Mhm. So Atif is asking, so can we have a separate circuit for each department and UPS?
I don't know what you mean. I don't
Mhm.
understand the question.
So Akash is asking how to decide matrix size, also how to decide on earth feet from earth mat.
You read the standard. As I said, India is the only country where standards can be downloaded at free of cost. Most of the Indian standards are freely downloadable. Go to the standard, go to the respective section, read it. They are very well explained.
So last question for the day I'll take. So Ganesha Prasad is asking, how can we achieve equipotential between metal parts and ground? Example, pipes are high potential at high potential and person standing on the ground at zero potential. So there exists a potential difference.
Yes, you have to make a potential grading on your building. This is called as potential grading.
Okay. Now I will try
Like
and
for example, the
yeah.
pipes are not supposed to have a potential stronger enough to create a shock for a significant time. Before that, the supply is supposed to be disconnected.
Okay. We'll see whether we can allow a few. Only two hands have raised to ask questions. So Rajan Bala, whether can I take him here? Rajni Bala and Sharavanan. Okay, a lot of people are raising their hand. Why? I think Lakshmi, can you make me host because I'm not able to, allow them to speak.
I can make it. There
Okay,
is a
okay, sir.
government hospital for chest gentlemen. Sir, you can unmute yourself and you can talk if you wish. Also, all the four participants I made, they can talk. Mr. Smriti Pradhan, you are welcome. Mr. Smriti Pradhan is from Orissa.
Sir, namaskar, sir.
Namaskar.
Namaskar, sir. Sir,
Yes.
actually, my question is that in a hospital there is a distribution transformer of 500 kVA, and
Okay.
the LAR thing, the neutral R thing, all these are to be connected to make a equipotential bonding.
You have to have one bus bar starting from the neutral of the transformer, running along with the phase and neutral up to the last socket, and you must bond everything to the common bus bar. The old name is equipotential bonding conductor, the new name is MET. Neutral of the transformer to be
Okay, sir.
connected to the MET, body of all the equipment including transformer to be connected to the MET.
Okay, sir. Okay, sir. Thank you.
Thank you.
Anybody else to ask question? Can you please unmute and ask the question?
Okay, I think if there is no question.
Rajni Bala, Shanwas, Jai Kumar, you can unmute and speak. Yeah, allow to talk. Yes.
So, Gopal sir, can you explain what are the primary cause of fire in UPS? Majority of the locations, majority of the this medical equipment, they contain the UPS systems, and quite often
UPS.
UPS system. So quite often I have witnessed so many fire during fire audits. even in this IIT locations also, in medical locations, so many fire incidents reported in the UPS system.
Okay.
So,
Are these UPSs tested according to the standard?
in fact, sir, I don't think they are tested, but the majority of the equipments are provided with the UPS system, and majority of the system fire was in the UPS itself. So I suggested them primarily to remove the UPS and keep it outside the particular hall or premises, so that immediate effect of the smoke and other consequential effect on the wirings, it should not affect the normal functioning.
Correct.
I'm
Because you
doubtful
cannot
that,
keep. Yeah. Yes, please. Please go ahead.
sir.
Please go ahead, sir.
Any
Good afternoon,
question,
sir.
sir?
Good afternoon,
I
sir.
will
I am
complete it,
Devendra
sir.
Kumar.
One minute.
My, my, my,
I'll just request the name, maybe because I am
yeah,
unmuted most of them.
I am.
Alkendra Singh, Alkendra, you can go ahead and speak.
Yes, sir. Good morning, sir.
Good morning,
Am
Alkendra.
I audible, sir?
Yeah, perfect.
I am audible, sir.
Yeah, go ahead, go ahead.
Sir, good morning. My request is that recently a new incident happened in the Jhansi neonatal ICU, and so many new infants' lives have been claimed. So, sir, as a NAP, we should form some corrective action zone-wise committees to know the lapses and participate in the incident to know the truth, and should brought to the notice of the state government to for as a remedial actions to be taken to avoid such incident. So this was my request, sir.
Thank you, thank you. You see, we are located in South India, and first of all, some of our members, those who are from that area, they should initiate this action. Would be nice if someone from NFE member from UP can initiate this.
Alkendra is
Thank you.
from Jaipur. This incident happened in UP. So
Yeah.
we'll see, sir. As we progress, we need more and more chapters everywhere. And as we get the strength that's the reason I'm asking everyone, please join NFE so that we can strengthen, we
Yeah.
can do our own case studies, we can examine the causes for the failure. So I would urge everyone to become a member. I think my colleague Lakshmi was in the chat box. You can see the link and become a member. So, Devendra Kumar, you can go ahead and speak.
Um, Good afternoon, sir. I am Devendra Kumar. My basic question relates with the earthing. So, in a power system, there are three types of earthing. One is the equipment earthing. Second is the neutral earthing or the system earthing. And third is the lightning arrested earthing. And all the three earthings are separately earth. Now, in case of hospital, now there are big hospitals where the power consumption is huge. So under that condition, there is a distribution transformer in the vicinity of a hospital. So there is a neutral earthing, then there is equipment earthing, and there are so many tall towers where patients are accommodated. So there also lightning arrested earthing is also there. So what do you suggest? Whether for all the three earthing, we have to have the three earth pits?
Sir, what do you mean by earthing? You mean earth electrode?
Yeah, earth electrode, sir.
That means neutral has separate earth electrode,
Yeah,
lightning protection separate earth electrode,
yeah.
and what was the last item which you told? The biomedical.
Equipment earthing, yeah.
Yeah. Since you asked the question, let me share and show you the figure again. I'm showing the figure. The idea of neutral separate, body separate, lift separate, it is totally wrong. It
No,
never
no,
existed. Yeah.
no. I'm
Now
not.
let me complete. Now
I'm
complete.
not
Now
saying
let
this.
me complete. Let me complete. Now clean earth, power earth, lightning protection separate. This is also a big mistake. In the standards, you can find this picture. And what is written in the standard is this is prohibited. You are not supposed to follow. Then separate, and underground all are interconnected together. This is also prohibited. Means you are not supposed to do it. What you should do is something like this. I will draw it for simple understanding. You take a bus bar like this red color line. Imagine it's a long bus bar. Neutral of the transformer should be connected to the same bus bar. Body of the transformer to the same bus bar. All electronic item, including lightning protection, to the same common bus bar. That is what is shown in this particular picture. Now, where you can find this information is there are some, this is from there is a standard called IS 3043. Look at the figure 38, 39, 40, 41. You can find it. So there is a common bus bar where I am reading. You see the yellow color common bus bar?
Yeah.
Everything must bonded to the common bus bar, including, you see, neutral of the transformer or DG to the same common bus bar. This is earthing. Separate connection is not earthing. That is connecting earth electrode. Basically, that is not earthing. This is how it is. Thank you.
Sir, my submission, I just want to clear my viewpoint because
Yeah.
I am an engineer, electrical engineer, and working for long in the power system, generation, transmission, and distribution. So you kindly the new power plants which are coming up, they are having bonding, but the old one which were commissioned somewhere 1977 onwards till 2022, they are having this system because if the distribute the power transformer neutral is earth, and if it is connected with the lightning arrestor, and if there is lightning, then it will enter into the transformer will be burnt. So if we are
So, sorry
yeah,
to interrupt. Sorry to interrupt.
yeah,
There are so many modern protective devices invented during the last decades.
yeah,
These devices together, if you make a good equipotential bonding and if you connect or use all the recommended protective devices, nothing will happen to your installation. Your entire installation can withstand light.
no,
If
I
you
am
put it separate, then you are creating separate potential. You are creating potential differences, which is hazardous. It is applicable. This philosophy is applicable not only for a hospital or a house, it is applicable wherever you use electricity.
so it means
Now,
it
the
means it
neutral,
means yeah, it
the
means in a
neutral,
power. It means
yeah,
sir
the
in
neutral,
a yeah,
let me finish that. Let me finish.
yeah,
The neutral, which has to be connected to the same common bus bar, it can be connected directly, which is called as solidly earthed system. It can be connected to through an NGR or through a neutral earthing transformer, or you can completely isolate. Different techniques are allowed. Now, for low voltage electrical installation, which is our primary talk today, you have a transformer, secondary side is 400 volt, 450 volt. In that case, solidly earthed system means the neutral of the transformer must be connected directly to the common bus bar. You cannot use it in a large power generating station because
yeah.
you have to reduce the fault current. So what you use is other technique, maybe an NGR. You put an NGR and reduce the fault current. Otherwise, the
Correct.
system remains common everywhere. Thank you.
So okay.
Okay, due to shortage of time, there are so many questions coming in again, and there are a lot of chat. But what I'm requesting is,
I would like
you
to
will
ask
find.
Mr. Dominic, there is one Mr. Ranadeva Chandra. He was talking in between.
Okay, okay, go
Ranadev
ahead, sir.
Chandra. Mr. Ranadev, you have to unmute. You have to unmute and talk. Okay. Anyway, okay. I think.
Okay. So most of the answers are you can find in our blog. When you visit nfees.org, if you're a member, I'm saying, if you're a member, you can visit our blog, and whatever the presentation that we have made, that is also available there. And if you see, you can also visit previous webinar. So most of the questions you can find the answer in the blog. So I would urge some of the question or chat box are quite common. Answers can be given in the blog, or you can put up your questions in the blog. Mr. Gopakumar, whenever he finds time, he will answer. Subject to you're a member of NFE, National Federation of Engineers for Electrical Safety. So I would urge people to become member of NFE for various reasons. One is you enhance your knowledge and you enhance your network. And like Mr. Alkendra said, we need more people to investigate what happened, the cause for the accident. NFA today need more and more professionals coming together and find a reason. Our objective is electrically safe Bharat. To make electrically safe Bharat, we can't have just 2,000 people or 3,000. We need huge. And we are creating a lot of mass awareness program through colleges. So we need more and more students to join. So NFE is a right platform for all the engineers, specifically from electrical background. Please do join. We will next webinar from NFE will be comparing international standard and Indian standard. How better are we and how better other nations are. So next webinar we'll announce the date on the next webinar on standard. We'll be talking about standards comparison between IEC and NEC. So I would urge people to keep in touch with us, and we will be sending communicating about this. I want to extend my um, gratitude to Mr. Gopakumar, the speaker, and our supporting organization, CAHO, AHPI, Focus, FSIF. Unfortunately, our keynote speaker, Mr. Deshmukh, was preoccupied with the urgent meeting, so he couldn't join us. So we have a lot of supporting fraternity in NFE. When it comes to fire, we can invite so many people. On medical, we have fantastic support from CAO and HPI. So let's keep continue this knowledge seminar webinar soon. We look forward to see you in Jharkhand, in Ranchi on 27th. We are talking about CA regulation and NEC, and we would urge people from Eastern region, please do come. My colleague again posted about the registration link in the chat box. You can look at it. Look on. So have a wonderful weekend. Thank you so much, Mr. Gopakumar, for joining. And you have any final word to the
Yeah,
audience?
the video of today's webinar will be available in our YouTube channel. The video will be there in YouTube channel. Probably people, those who wanted to go through it, they can do it. Thank you.
Okay.
Thanks to all. Thanks, Mr.
Thank
Dudley.
you. Thank you. Have a great weekend. Thank you. Bye-bye.
Thank you.